Welcome to the video on frequency response of amplifiers. Here let us see a typical frequency response curve of an RC coupled amplifier. In general, the frequency response curve is a plot between the magnitude of gain and the logarithmic frequencies. While plotting the frequency response of a circuit, it is conventional to use a logarithmic scale along the x-axis or the horizontal axis so as to permit a plot extending from the low to the high frequency regions. So in general, any frequency response curve can be split into three different regions. So let us see the first region over here as a low frequency band region. The middle portion is called mid band region, and the last portion is of course called to be as high frequency band region. So let us see one by one. Before that, let us first see the main reason for the drop in the gain at the low frequency region and at the high frequency region is due to the increase in capacitive reactance in the low frequency region and due to the parasitic capacitive elements or the frequency dependence of the network's gain on the active devices at the high frequency region. So this is going to be the main reason for the drop in gain in both these regions. The frequency boundaries of relatively high gain region is determined by choosing 1 by root 2 AV mid to be the gain at the cutoff levels. The frequency corresponding to such levels. So could you see this? This is going to be the level. So such values are called F1 and F2, or you can even call it as FL or FH. So they are called to be as cutoff frequencies or the band frequencies or the corner frequencies or even the half power frequencies. Okay, so the bandwidth of any system is hence given as bandwidth is equal to FH minus FL, or you can even write it as F2 minus F1. A decimal plot can now be obtained by using the following transformation, that is AV by AV mid is equal to 20 log 10 AV by AV mid. So the gain at half power point becomes 20 log 10 into 1 by root 2, which is nothing but minus 3 dB. So that is why we draw a line which cuts the plot. So see, can you see a 3 dB line? So that 3 dB line where it cuts that point is said to be as FL over here, and that point over which cuts the plot here is said to be as FH. So now let us see one by one. So the mid band region. This is going to be the frequency range of interest for amplifiers. And in this region, the large capacitors can be treated as short circuit and small capacitors can be treated as open circuit. And the gain is constant and can be obtained by small signal analysis. So in the mid-band region, you could see a straight line, that is gain is almost constant over here, and all the capacitance can be neglected. Next, we are moving on to low frequency band region. So this is going to be the region. Gain drops at frequencies lower than this FL. Okay, and large capacitors can no longer be treated as short circuit, and the gain roll off is mainly due to coupling and bypass capacitors. That is, gain falls off due to the effects of this coupling and bypass capacitors in the low frequency band region. Next, let us see high frequency band region. The gain drops at frequencies higher than FH. Smaller capacitors can no longer be treated as open circuit, and the gain roll-off is mainly due to the parasitic capacitance of the MOSFETs. So in this high frequency band region, the gain falls off due to the internal capacitive effects or the parasitic capacitances of the MOSFETs or the BJT. So I hope by watching this video you would have understood clearly about the frequency response of amplifiers. Thanks for watching.